Hello there, I'm Ioannis from T-Lab, the designer of the micronode boards, and today I want to show you how you can use a typical micro USB to serial port adapter to program your micronode board in case you have done something wrong in your firmware or if you need to reflash from scratch your firmware. Many people actually have trouble trying to keep the pins together onto the pins or the pads of the micronode. That's why I want today to show you a typical rig that you can build at home that can help you with this programming task. Let's have a look. So here we have a typical breadboard that you can find in any electronics store. What I'm trying to do here is create some receptacles here that when I press the board against will hold it in place and help me program this hands-free by putting the FTDI adapter somewhere else on the breadboard. Without this setup, what you would normally have to do to program this device via cable is to put your FTDI adapter on the programming pins down here, make sure that the ground is aligned with the ground, and then you also need to connect the RTS pin with the reset. So the last pin here is the reset, and the RTS pin is located somewhere on your device. So for me it's here on the side RTS. Now you will also need to hold all these pins together while you program it, make sure it's very steady, and make sure, of course, that you're programming it at 3 volts. Now, a few things can go wrong with this setup. For instance, not all these devices are powerful enough to provide the current the ESP chip needs to be programmed. So if you're working at 3.3 volts, usually you don't have enough power to program this. Also, there are some software incompatibilities between the Arduino interfaces or the programming software you use to flash your ESP that are not properly controlling the DTR and the RTS pin that controls the boot process of this device. So using this rig here, you can actually make your life much easier and make sure that you flash your device correctly. Now let's see how to do this. So I placed some male-to-male pin headers here on the lower and the upper side here. These are aligned with the programming pins here at the bottom and the power pins here on the top. I also make sure that I put these pins one step ahead, one step further than would normally be located. That's because I want to increase the tension when I press this device against and making sure that all the contacts are firm and correct. So let's try to put this board here. I just align it with the bottom pins, make sure that the last one here goes well, nice, and then as you can see, it's overshoot a bit. I'm pushing these pins towards the board and push it down to make sure that they have a firm and even pressure all along the board. I'm also putting another long pin here on the side to push this side of the board and make sure that their pressure on the lower pins is even. Now you can plug in your FTDI adapter and you're ready to program the board. Now let me show you another trick. In order to put this device always into programming mode and make sure you don't have this ESP uploading errors that you see on the terminal, you can connect the DTR pin, that's one pin from last, with the ground. You can either use this ground or this ground, they are linked together. So what this will do is will instruct ESP to boot into programming mode no matter what's the configuration or no matter what's the external conditions. So if you reset, or if you power cycle the device, it will always boot in reset mode. Now, these are some new devices that I just soldered. They don't have any firmware inside, and we're gonna do the first flashing of the firmware. Now, let's go to the computer. I use Platform.io as my development environment. Platform.io is just like Arduino, but it's just command line based and helps me with my pipeline. What I'm going to do is I'm going to flash a typical Hello World example that you can find on the examples directory from uNode, and I'm configured it to use ABP activation over LoRa. So this is going to send a packet Hello World over LoRa, and when completed, it's going to make 5 rapid blinks. With this example, I can also test most of the hardware of the device. I can check the power to make sure that it's working, obviously. I can check the LoRa chip if it's working correctly, because if the LoRa chip is not working, I'm going to get an exception and nothing will happen. And I'm also testing the activation of the power of the peripheral devices because this is how the LoRa chip is activated. So let's try to compile it. Platform.io run. This was going to compile the chip and make sure that the code and make sure that there are no errors. Here we are. And then I can use target equals upload to upload this on my device. When I hit enter here, it's just gonna reset the board and program it. Now, as we can see here, the device is being programmed. We see this nice blinks here and on the FTDI adapter, so we know that things are working. We can also see the progress on the terminal, and a few seconds later, we're gonna have our device flashed and ready to be used. Success! Our device is flashed. And we see 5 rapid blinks here, which means that our device is working correctly. Now, since the device was booted into programming mode using this trick here, it was then reset by the flashing firmware into operation. But if I keep this wire here, every time I reset it, it's gonna go back into programming mode and never gonna run my sketch. To avoid this, you just need to remove this cable when you're done programming. Now, every time you reset, it's gonna go back to your sketch mode. And for example, in our case, in a few seconds we will see this rapid blink. This is how you can program your micronode using an FTDI cable. This was the tip I had for you today. I hope it's gonna make your life a little bit easier when you're programming the micronode boards. I'm really looking forward to your feedback. Tell me what you think about the micronode board. Is it working for you? Is it not working for you? We're definitely gonna make a second version and your feedback is important. Thank you and have a nice day. Bye bye.